It's great to be with everybody once again. In this video, I would like to talk about the basic science behind the SARS-CoV-2 virus, what we've learned so far, what we know, what we don't know. And one thing I can't talk about is what we don't know that we don't know. And there's a way more that we don't know than that we do know. And so after this video, hopefully you'll know a little more, but we have to realize that what we know now will probably change and be different. That's how science works. Science is a continuous thesis, antithesis, and synthesis. That's what happens in science. You have competing views, and we learn sometimes they're both false, sometimes they both have a partial truth, and then you learn and you move on. That's how science progresses. Science is not absolute. There's not an absolute truth in science because we can't know everything. We actually are in the test tube of the scientific experiment. In order to be 100% objective, you have to go outside of the experimental box. For us, the experimental box is the universe, and there's really no way for us to go outside the box. We actually take part in experiments. We are part of the experiment. There's no way for us to ever be 100% objective with any scientific research because we are subjected to senses, sights, sounds, gravity, the electromagnetic fields of the Earth's force, gravity, all these things that affect the experiments themselves affect us, affect how we interpret data. Our language affects how we interpret data. And so what that means is we ourselves are part of our own experiments subjectively and objectively. And what that means is our findings can later be found to be false. And we see that with about half of all scientific research. The findings are later found to be false. So that's my short snippet about what I'm saying right now may later be found to be false. It's what we know today. As of July 19th, this is the state of science in the SARS-CoV-2 world. So hopefully this is helpful. First thing we need to think about is that the first coronaviruses came to existence on Earth about 10,000 years ago. Even later, some suggest, potentially millions of years before that. That's not quite known, but it's at least 10,000 years ago was the first coronavirus. And there's 7 strains that affect humans. 4 strains cause common infections that we see all the time. About 15% of head colds, respiratory tract infections are some type of coronavirus. And about 30% of infections during an acute flu season are coronavirus. The other three coronaviruses that are serious are SARS-CoV-1, which is the original SARS, SARS-CoV-2, which we're dealing with now, and then MERS. Now, SARS-CoV-1, 2, and MERS, MERS and SARS-1 both originate in bats. And so there's a lot of these viruses actually start either in bats. The SARS-CoV-2, which is what we're dealing with now, started in a horseshoe bat. And what happens is this virus starts in some animal, like a bat, and then has an intermediate animal it goes to. And that intermediate animal, there's some kind of mutation that then allows it to be transferred to us. This is how the flu works. Flu typically starts in animals, pigs in China. It's transmitted to duck or geese. They bring it to the United States. Eventually humans get exposed, and that's kind of how the flu works. And so that's the reason why we have to start making our flu virus about a year in advance based on what's going on in China. And we figured out with the H1N1 that started actually in pigs or swine in Mexico, totally different, caused by surprise. But this is a very typical way these viruses, this interaction between humans and the animals around us. So the intermediate, so with the SARS, there was actually civet cats were the intermediate. And these are these cute little cats, and they're eaten for food in China. Sometimes slaughtered, eaten at the space. So whoever's eating that animal is getting this exposed to this. So it's in these wet markets, there's a very, very close contact between the animals and the humans. Most people in America today don't have a close contact with an animal outside of a cat or a dog in their home. In these situations, you go to these markets and there's hundreds or thousands of different species with interaction with people. With the MERS, the intermediate was a camel. Okay, so it went from a bat to a camel. Humans ride camels in the Middle East, and that's how that spread. Fortunately, that was not very transmissible between humans. So the viral origins. Now, the thing about the current coronavirus is that there's about 96% of its genetic material has been shared with the virus bat that's been found in the cave in the Yuan, China. We think that's where this originated, and that's where some of the controversy comes from, because that's the area where it originated, we think. It's about 500 miles away from the wet market where eventually the spread occurred, as far as we know. Now that 9%, 6% change in genetic material, it's still not 100%. And it takes sometimes a decade or so to get that much variation in a coronavirus. So we have found some other, the Malayan pangolins is another animal we think it may have been a genomic origin for the SARS-CoV-2. However, the virus in these Malayan pangolins, which are these cute little critters, they kind of look like an aardvark kind of sort of, they only share 92% similarity with what's going around right now. So that's unlikely the source. It's probably these civets. So the thing about it is that the virus in the bat initially does not infect people, but it's this intermediary that gets it and gets a mutation or change that can infect people. But the big thing about it, I think what this means for me is that because it takes such a long time to get this genetic change, we're probably not seeing a huge variation or genetic variation. We're not going to see one in the current virus. There has been some reported change, maybe there's 2 or 3 strains going around, but there's not enough genetic difference for it to be a totally different viral infection. The degree of severity of this infection, which is a big issue at hand, has more to do with the amount of exposure of the virus than the strain per se itself. And we'll talk about that here in a second. So, so what we need to do is we need to find an animal host version that's about 99% similar to find the SARS-CoV-2 to know what we're dealing with. And unfortunately, we're not really getting in. We're not being allowed to go research and find that right now. So we're kind of going on the knowledge, information we have. There's also some question about the information we have just due to the fact that there was just some mishandling with the information. There was some initially we were told it wasn't infectious by Chinese researchers, and the World Health Organization spread that information. So there's been just also some misinformation throughout this time. So I tend to like when I find research articles talking about this originating in China, I tend to like to find a European counterpart to verify it just because of the degree of misinformation. So why do people, okay, this is a big question. Why do people respond differently? You know, there's different factors. There's genetic factors. We do know some genes associated with severity of SARS-CoV-2, like an ApoE gene. If you're ApoE4, you're more prone to inflammation. You can clear the virus quicker if you have the ApoE4 gene, but if you're already inflamed, you're also more prone to an inflammatory response. So the gene can either be typically is beneficial, but if you're someone who's obese, diabetic, who's already inflamed, then in you that's going to cause a low-lying inflammation. This ApoE4 gene is also associated with an increased risk for cardiovascular disease as well as Alzheimer's, dementia, and certain cancers. So it's an interesting gene. There's also some data about blood types being more susceptible to this infection. These are interesting points, but the biggest factor related to severity of disease is actually two factors are the exposure, degree of exposure, and the person's underlying immunologic status. So what do I mean by degree of exposure? So it takes if you get about 10 viral particles exposed into your respiratory tract, which is not a lot, it's not going to make it down to the base of your lungs. So the infection will most likely stay in your upper respiratory tract. You'll sneezing, coughing, maybe a loss of smell and taste might be your only symptom, which we've known that since March, April timeframe. And you'll be better, you'll be fine. It takes about 100 plus viral particles to be exposed to get it down to your lungs. And that's where you might get the viral pneumonia. If you get a huge, huge exposure from a COVID-19 party, which is a terrible idea, if you're actually working in the hospital and someone is being nebulized, in my area, there's a skilled nursing facility where people were being nebulized with nebulizers to treat asthma, and they were getting nebulized with large amounts of viral particles, probably getting millions and millions of these viral particles. That almost assuredly will lead to an acute respiratory pneumonia type infection. And so the first thing is the degree of how much you get exposed, hence the utility of wearing masks and social distancing. If you're far away from someone and you wear a mask, when you get exposed, you just won't get exposed to quite as much. The other thing is your underlying immunologic status. If you're someone who's already inflamed, you already have elevated inflammatory markers like IL-1, IL-6, your CRP is already high. We actually use HSCRP, which is a high sensitivity CRP as a marker for heart disease or risk for heart disease. If yours is already up a little bit and you get exposed to this, you'll probably have a very robust inflammatory response. And that's what we're seeing, is we're seeing a different expression of this inflammation when people are exposed. The other thing is your nutritional status. we know very clearly that if you have a low vitamin D status and you're exposed to this, you're more prone to have an inflammatory response as well. Why? Vitamin D is required to make antibodies. If you have a high vitamin D level, you make antibodies more robustly. Your body controls inflammation much better. If it's low, it's going to take your body a while to make antibodies. Hence, vitamin D status is a huge, huge factor. There's also some gene variant stuff we talked about. Neutralizing antibodies. So we've learned a lot of things about neutralizing antibodies. The first IgM antibody, which is your antibody for fighting off an acute infection, hits its peak in about 23 days. The IgG goes up in about 49 days, and you tend to have the IgM go down after 4 to 6 weeks. The IgG may go down in about 3 to 4 months. For more severe infections, these antibody levels can stay up for much, much longer. There's what we're learning about the underlying biology of this infection is that some people will have a quick infection and their antibodies will be gone pretty quickly. Some people will get infected and the antibodies will be gone so quickly that we can't even pick them up. A lot of that depends on how robust of an immune response a person has, how long they are around the environment, how much they're exposed to. But the antibodies do not correlate with the person's underlying immunity status. It's a surrogate marker. It's the best we have. It's what we're using. The best marker for immunity is actually neutralizing antibodies or B memory cells, which we can't really measure clinically to date. What would be great to know is actually IgA antibodies, which are most of IgA represent the vast majority of all antibodies made in our body, and these are actually secreted along respiratory tract, GI tract, lungs. You want these levels to be high, and actually right now most testing is not for secretory IgA, it's for IgG antibodies. So we're actually not even testing for what represent our respiratory tract and GI tract having immunity. Virus mutations we mentioned. Reinfection to vaccination. Your vaccination, again, when we get vaccines, the vaccines are actually, the point is to produce antibodies to the spike protein, and that's how we've learned how this thing actually enters our body is through a spike protein. The spike protein attaches to the angiotensin 2 receptor, which is mostly in our lungs. It's also in our GI tract. It's in our arteries. It's in our vasculature and our kidneys, which are some of the places we see severe disease happening. And this is how it gets into our body. If you have an elevation of these receptors, you tend to get more infection, and certain ethnic groups have this elevated. Certain disease states will see this elevated, and some will see it lower. So if you actually are taking an inhaled steroid for asthma, you actually that's actually protective against upregulating the angiotensin 2 receptor, so you actually will get less severe infection. As far as current trials, vaccine trials, there's over 200 trials in development right now. In development, there's 2 that are actively working on phase 2 and phase 3. And we're waiting the placebo-controlled trials. My research group actually is going to be involved with a phase 3 with the vaccine with Pfizer, and we actually are starting that in the next week or 2. Moderna's hit most of the media. Most people are familiar with that, but there's other 20 other companies right now doing studies. And the vaccine, the big thing with the vaccine, I think, is to find out, when it's deployed, we'll find out how well it works. But vaccines typically, when you deploy them, you create a vaccine antibodies like the flu vaccine. Like there's actually a vaccine in development right now for C. diff colitis, and these create antibodies. That's what vaccines do. They create antibodies, and that's how they confer immunity. So hopefully that was helpful. That's some basic science we understand behind what's going on with COVID. Its origin. This is changing. It's in flux. It's in motion. So hopefully, as new updates come, we'll making you all aware. Please continue to follow us on social media, YouTube, Facebook. If this is helpful, share it with your family, friends. If you have questions, please post them, and we can, as time allows, answer your questions. We're here for you to help kind of guide you all through, lead you through, answer your questions, concerns, and queries from hopefully evidence-based, middle-of-the-road kind of stance to help us all get through this. Take care, be blessed, and stay safe.